Okay, let's start. Let's again welcome Jigar, who is in the Pacific time. So I think he's still kindly giving up his time in the night and after attending a interesting, hectic workshop slash conference, is still eager to share his learnings with us. So over to you, Jigar.
Thank you. Good morning, everybody. Let me just make sure I can see you people. So then make this one. Okay, good. All right. Everybody's awake? Yes, good. Okay, so just continuing from yesterday, I just want to give you a little bit of reminder, given that you guys had so many talks. We spoke about mostly a couple of health projects that I've worked on, but really giving you a sense of sort of how applied research maybe happens or applied solution building happens. The first one was the LLM project, LLM Copilot for healthcare workers. And then towards the end, we kind of briefly touched on the cough project, TB cough and COVID cough. Okay, today is different topic. Today is a somewhat more mature project, an older project that I worked on, still going on. This is on agriculture. So that will be the first half. And then the second half is sort of a meta talk on how to do the building, right? The general principles of how to do building, and then what problems to work on. So I've just a couple slides on at least my personal take on how to pick good projects or problems. Okay, so but first, some pretty pictures. Okay, so I want to tell you about this project that I worked on at Wadhwani AI, which is second. How do I make this? People are too big now. Okay, early pest warning for cotton farmers. So the idea is that cotton farmers across India, we want to give them the advisory on when to spray pesticide to protect their crops from pests. And this is a mobile app. This is an app. Okay, what it is very simply this workflow, and then I'll tell you sort of all the variation and how we got here. So I want to tell you the end first. On the left is a pheromone trap installed in the farm, and then they open the bag at the bottom, put it on a white sheet, take a couple of pictures, which is number 2 here, and then they get an advisory. This advisory is based on the pest size and count, and this is well understood by the agri world. So we didn't do that. We did the computer vision part of it. But just to give you a sense of why this is critical for India, it is important because India produces 25% of the world's cotton. 41% of our of cotton in the world is in India, and this is also, if you can see, 25% of production, but 41% of the land means our yields are lower than some of the other parts of the world. One of the key reasons for lower yield is pests. Just to give you a scale, about 6 million actual cotton farmers in India. Most of them are smallholder. Smallholder here means they have a land of small size, but more importantly, this is their major source of income. So if the yield is not good, then they go in debt spiral, right? So next season they cannot sow enough pesticide, they cannot afford, and so they get even lower, and then as we have seen, some farmer suicides happen. This is partly because of this debt cycle. And one of the key reason for low yield is pesticides, very simply. And so this is how we sort of came about to the problem that, look, this is a problem. It affects a lot of vulnerable population. What can we do about it, right? So this is just to give you a sense of how this. I have another one, yeah. So how this pest attack happens. This is a 24, 25 week cycle from seed to the nice fluffy cotton ball. The pest, the larvae, lays the egg during the bloom part, right? It's in the flower part. And then what happens is it closes up. It's like a very tough ball. And then it takes few weeks and then it opens up and there is the nice, beautiful cotton. Now, the thing is, once the eggs are laid and the bowl is closed, even then you're basically done. Because if you open the ball, then you have your cotton is not grown. And once the bowl opens later, it's all black. So it's not really sellable in the market, right? And so basically, I've gone to several farms in Maharashtra, Telangana, Punjab, and like the farmer will say, I'll open anything. The whole thing is screwed up. So you open any bowl and it just is brown, right? So it's not sellable, that cotton. So this is the problem, right? What the pest does and what is the effect. As I explained, it starts with this trap, pheromone trap. If you can see at the top, there's this lure that attracts the male bollworms. And they get trapped in there. And the protocol is for them to then every week, it also traps a lot of other dirt and other kinds of pests, but also the main one, right? The bollworms. And then they open it at the bottom and take picture. So yeah, I think I showed you this. On the left is emptying the trap, taking the picture, and then they get an advisory saying, hey, you have a lot of pests. So for example, if they only see one or two, then you say, it's okay, you can maybe not do anything, it's not so severe. If they have, I think in 4 to 6 or 4 to 8, then you say it's yellow alert, and maybe you do organic pesticide. And then if it's a lot, then you say, do go all the way. The thing to consider is, in absence of an advisory, what tends to happen is either there is some superstitious, non-scientific way that the farmers would do it, or out of fear, they'll overspray the pesticide, right? So to just make sure that something comes, they'll just spray it. So now there's two issues with this overspraying. One, it increases their input cost because pesticides are not free. So their net profit is thinner now. And the second is these pesticides also create a climate issue. So they will degrade the soil quality over time. So actually what happens is over time, they need to put in more and more. And so this is a sort of slow death if you overspray, both of your soil and of your income, right? So yeah, this is the main point. So when we started this back in 2018, many years ago, these were the data sets. One is terrible data sets, or there were other very nice academic American data sets, but they were like pictures like this. And one thing to consider is these are, although the same pests, but it's totally out of distribution, right? This is like nice DSLR pictures taken. So we basically had to go collect data. There's no choice. So we went and installed these sticky traps, gave the protocol, and this is what they look like. These are some of the nice ones. Actually, initially we were trying to use some of these, like some numbers of some of these numbers to track when and what was taken, but then we moved on to another solution. Yeah, so these are, as you can see, several things. One is the scale is a problem. Two, sometimes these are broken pests. So the leg is dismembered or the wing is on the other side. Now, how do you do the count, right? And count is very, very critical. So this way, it's somewhat challenging object counting, object detection problem. So we started very simply, given that we didn't have too much data at the start. We use SST model. This is very, at the time, quite standard and useful, and still is, I think, in a lot of useful settings. Get a count and get a recommendation out of it, right? Very simple, very straightforward. But we noticed something. As we did a small study, here I'm on the right, I'm showing you the x-axis is time and y-axis is different farms on which we were trying this. That it was taking a long time for them to upload, and there were a lot of drop-offs, which is not here. So basically, unsurprisingly, that the internet is not reliable. Although naively sitting in Mumbai, we could think that geo is everywhere, but in the farms, not so much. So this led us to, this is one lesson, and then I'll tell you how we sort of overcome all this. The second one, in real world, people will use it any way that they will wish. So actually what they did was initially they would take pictures like this of the bike or of the tree, and the model, because it has not seen too much data, especially not too much out of distribution data, it would give some wrong alert, right? And this led to a lot of mistrust, especially given that we were asking them to take a big step, something that is very dear to them for their livelihood. This degraded trust initially. If they had put it on a white sheet and then it would have worked. But this also led to, some of the challenges are of this form, where they took a picture. I mean, this was laughable. In fact, this was part of our CEO slide at some point, that if you if you squint, then it looks like tests, kind of looks like that, white background, different things on top, but obviously it's a bed sheet, right? Or they would put some other stuff on the paper, right? So we had these issue that even though we had little bit of positive, I think at the during this time this was just when app began, so we had about 3,000-4,000 images, but the scale of negative was really big. So we had to figure out something. Obvious thing to do is we built a classifier and said, so this was second version, where we build a classifier and say it's a valid image, right? Valid image is the white background with test looking things. That's valid. And then the count model gives the count thing. And invalid, then we reject and ask them to take the picture again, right? So they'll get a bad photo quality, and please take the picture again. In fact, later on, we also tried to use some specific feedback. So we had also built classifiers with an intern where we would say, hey, it's blurry, or it's too close, or it's too far away. So we can give them more fine-grained feedback, but that didn't really make it to production. And of course, because we had this issue of internet connectivity, we did compression, right? So we compressed the model down, all of this, such that it fits on the phone and they can get offline prediction. Okay, so this is version 2. So just reiterating several. Wait, one of the slide is missing here. Oops. One second. Okay, fine. Okay, so this was version 2. The other thing that we had, so let me talk about this and then I'll go to the slide before. So first let me explain the graph and then I'll tell you what's the issue. On the x-axis here is time, and these are seasons, right? Because cotton is seasonal. K18 means Kharif, right? Kharif is fall in India. So that's fall season growing. And then S is summer. Okay. So these are different deployments that we had. And on y-axis is the model accuracy. Okay. The terminology that I would like to tell you is about this subscript, the H and the P. Okay, so you can see K18P, K18H. I don't know if you guys are too far, but there is the PH. What it means? H means I train data all the way before the season started, and then everything that comes from that season is in my test set. Okay, this would be like a simulation of deployment, right? I freeze my model, I train everything that I have for now up until time X, and then what comes from the field is my test set. The P means that I combine everything from the from that season too, and then I do typical train test split. Okay, so what P means is during like I have data from that season or from that farms. Unsurprisingly, if you follow the blue line here, me going from, so let's look at K19H and K19P. K19H has a mean absolute error of about 4 something. Lower is better here. Right? This is mean absolute error. And then if I have data from the same season, then the performance becomes better, right? The MA goes down. And then same thing again, what happens? I start a new season and my performance goes bad. But then when I add data from that season in, my performance improves. And then same thing, this thing keeps happening. There is this big spike here in performance. This is because we entered Punjab. Until this, we were in Maharashtra and Telangana. This one was when we did in Punjab. Very different phone types. In fact, Punjab, somewhat richer farmers. So some of them had higher quality phones and well, it's still out of distribution for the model that we were training. Also different lighting condition, different kinds of, yeah. So we had a very bad performance in this setting. Okay. Now the next thing I would like you to pay attention to is this rejected. Okay. What this means is if I am allowed to reject 0.1, so 10% of samples, right? Reject means I abstain from giving any prediction. I say, look, this is too different or out of distribution, and I'll abstain from giving any prediction. And we see that if I allow myself 10% abstain, then I suddenly get into very useful territory. This is the gap here, right? So with 10% rejection, if from a product standpoint, I'm okay with 10% abstain, then I am almost guaranteed to have good performance, like very good performance, right? Now the question became, how do we select this 10%, right? So this is this is to show that when your data set is not totally in distribution, maybe because of lighting, phone type, anything else, the performance does dip, right? And this is true for any benchmark, right? So you have a benchmark, ImageNet or what have you, you can do this, but then as soon as you take it out in the wild, your performance is going to be worse. But then from the wild, if you take some samples, put it in, train it again, performance increases, right? So this way. But now the thing is, it's a chicken and egg problem. I cannot deploy in a new region reliably without having data from there. But I cannot get the data if I don't deploy, right? You see, so this is a scaling problem. So what do? We say abstain for the moment, right? So if I can do 20% abstain in a new region for one season, then next season I can do 5% abstain, right? So this way the product people and program people can maintain trust in the system while we get to collect data, right? So this is a way both to make reliable systems, but also scale product quickly. Okay. So this slides got reordered. And the other thing that we realized was if we abstain, then what do? We still, like, they took these pictures and I'm saying, look, your photo is valid, right, from our previous figure, but I'm not going to give you count because I've not seen this kind of image before, right? Basically, this is the rejection criteria. What we did, let me just go to this one, this is the final, this is the big picture here. So on the left, we have the compressed mobile model. If it says it's invalid, then it rejects and they take more picture. If it's valid, then it gives a count. But if it gets triggered for abstaining, because, and we have a paper on all the techniques of how we do this abstaining and study this, then it'll wait for the internet connection, go to the cloud model, right? So this is what I'm, oops. Yeah, this is what I'm showing here. My ordering got messed up today. So we say that in roughly 24 hours, but mostly it was as soon as they got internet connection, they would get a response from a much bigger model, right? So this would be your VITs or some of the other much bigger models. And even there, we use the same technique. Even there, if it couldn't do it, if it abstained, then we had humans sitting. And so this way we could have this escalatory system using abstain, going from local to cloud to human experts. And this way we could scale it much faster with confidence. And also it's interesting from a machine learning standpoint. Okay, the other thing that we did was this. At the time, we had collected about 20,000 odd samples already, 2022. So we started to partner and we got some grants. So we said we'll run a data set Kaggle-like competition. We didn't run it on Kaggle, we ran it on Zindi. This is just another platform, same thing. And I'm a big believer, especially for academics and nonprofits, where we don't have to keep what we do closed, that we could use the community. And we got really good results from all over the world. So here I'm showing sort of what the yellow is our team's submission or a default baseline. This is Team Cotton Ace. Green is the median, but we got some really good performance that beat us. And which was interesting, nice to know. Turns out top four, most of them use YOLO. They played with the training image resolution, which is something we never tried. We never really tried to blow it up because the actual image resolution wasn't that big. So it was very interesting, some of the things that they tried. They did this augmentation of mosaicing it, doing mix-up. I can tell you all. And then they also did very nice handcrafted like NMS non-maximal suppression techniques so that they could get the right bounding boxes. And obviously, like any other Kaggle competition, a lot of people did ensembling together to get good performance. And partly this cloud model here, that we call it cloud model because it's big model, small model, it's an ensemble of like 3 or 4 different models. And if all, and if majority abstain, then it's an abstain. Otherwise, we take the count. Okay. Yeah, this is where we are. Another thing I want to tell you is typically MAE or mean absolute error of the count makes sense. But really from the business side or from the usage side, it wasn't exactly the count because these counts had different meaning in different states. So from a user standpoint or business logic standpoint, it was red, yellow, green, as I said, right? It's just three categories. Now, initially, we thought we can just build a classifier. Why not? Right? Easier to build a classifier than a counter. But fortunately, we didn't because different places around the country have different rules, right? So if I get a count, then I can give red alert in one place and yellow alert in another one. So I can use the same model across. This was one choice of modeling, which gave us flexibility. The other thing, oops, I don't have that picture here. Okay. The other thing was also that after a certain count, for example, 20 is the number. Beyond 20, your field that is full of infestation. And so it didn't really matter if the actual count was 35 and you said 30. Okay. So this is where we had, even in the competition, clipped the errors. So we had a different kind of metric that we had come up with, which is MAE 20, where your errors above 20 weren't penalized because it didn't matter. So this is some of the things that even within, when we were measuring model performance, the best model was terrible at dense counting, for example. But dense counting in certain situations mattered, but in my situation didn't matter, right? So then we had to come up with our own metric. So I think this is just another applied things lesson. Yeah, all this data is open sourced. I think there's a lot more now. And some of the details in this ICLR workshop paper. Yeah, you could just use it. I think it's on Hugging Face too. So you can try. There's also a bunch of reference models if you want to play with it. What is the impact of this? This is the oldest project that we have worked on. There was a evaluation done on the farmers that used it and didn't use it. And the two key numbers, as I said earlier, there was about 20% reduction in usage of pesticide and also 25% increase in profit. Those are correlated variables, but they have different meaning. One is the input, the other one is the output. As of 2023, there were about 500K farms. Since then, I have left the institute, so I don't have the latest number, but now it's part of the national pest surveillance program, right? So in a way, like for startups, maybe acquisition or IPO is like the North Star. In non-profit world, getting somebody to pay perpetually is like success, right? So this gets graduated up, and a bunch of these awards and recognition happen along the way. Yeah, I'm going to switch gears. So let me see if people have questions, thoughts, if you want to learn something more about anything on the pest management.
Question. So,
Yes.
the early stage when you were collecting the pest in that trap, so in that video I saw that multiple of the pests were still like alive.
Alive, yes.
So two things. So if they are alive, won't it hurt the count? Because when you are capturing the image, many of them must have flown away. And
Yes.
if they are dead, so doesn't that like impact the ecosystem?
If they're dead, does it impact the ecosystem? Okay, so one, this is a picture that we took. Ideally, what they're supposed to do is take a picture every week. And so if you take it in a week, then most of them will be dead. If they are not dead, it does affect the count. So I'm right. So you're right about that. The second question was, killing them, is it bad? Is it wrong? Is that kind of what you're hinting? Killing the pests?
Yes, yes.
Yes. Well, that's a moral question that you have raised. I'm a hardcore vegetarian, so I am with you. But they anyway spray pesticide. You see, So they anyway indiscriminately kill it, right? It's poison basically for the pest. It is. I'm with you. This reduces pesticide use. In fact, this also encourages them to use organic pesticide, neem powder, things like this, which will deter the pests, not kill them, right? So that way, the hope is that through reduced use of pesticide or appropriate use of pesticide, that you allow the ecosystem to live, right? In many ways, these pests are part of an ecosystem, but from a farmer standpoint, they are pests to them, right? Just like in our houses, right? Rats are pests, but rats are part of ecosystem. So I don't want to kill the rat, but I wish they didn't come to my house, right? So this is more of that. Yeah, but good question. It's a moral question. Yeah, go ahead. Anybody else? No. More questions? Okay. Okay, so I'm switching gears. Now this is like the somewhat meta part of it. And I thought I'll begin sort of maybe telling you a little bit about my story of how I got into doing this kind of AI for social nonprofit stuff. So the story begins 2017. I was at this company called Crowd AI. It's a YC startup in Bay Area here. It was. And we were building stuff like this, right? It's a large scale, planetary scale segmentation model. Just to give you a sense, like this is digital globe imagery. This is actually very, very high resolution. I've just made it small. And then this is the segmentation, right? So the white here is the buildings, and then the black is not buildings. It's just a binary segmentation model. The image here is post forest fire, I believe. Yeah, this was post forest fire. So if you can see this is the burnt part. And that shows up in my segmentation, right? Unsurprising. And so, and we just had this model. Part of the startup was to sell as an API, right? So some company will say, for this location, give me all the buildings or give me all the cars or that kind of thing. I was at in this ECCV, I think, ECCV Germany, and I was having some drink with Saikat. I had known him before. He's one of the co-authors here. And we were just chatting. He used to do satellite stuff in Facebook at the time. And I said, hey, look, you know, these segmentation model now are really good. Maybe we can write a paper on like some doing some change detection on disaster stuff, right? So, and we kind of went back and forth, and he said, yeah, why not? Let's do it. And I think the deadline was maybe in a month or something, and we just did it over the weekend, submitted it, got accepted. Not just got accepted, there's like a bunch of news and press articles, and Jan LeCun tweeted about it, and blah blah blah. But that really opened up my mind that my skill set can be used not just like for companies to make money and money for myself, but there is a broader impact that I can have. I mean, maybe it's very obvious to you guys, and it's obvious that we are sitting in AI for Social Good summer school, that it's obvious now, but it wasn't obvious to me. At the same time, I ran into, just coincidentally, I ran into Anandan here on the right, bottom here. When I was presenting this this satellite paper, and he said, well, what good is this? Is this going to stop the fire? Right? He asked me some very fundamental question, saying, yeah, but you can tell me, but what good is it? Are they going to prevent flooding? And I was like, yeah, you're right. This is good, but it doesn't really change anything. And he said, look, we are building this institute in India. This is these are the Wadhwani brothers, all the way extreme right and left, and this is the inauguration. and said, look, we are building something where we really want to close the loop, right? It's not just AI, not just data, not just product, but that it goes into the hands and there is real social impact. And this is when I sort of kind of realized that it's not easy, but it's something that is worth pursuing. And then, I don't know, a few months later, I got convinced and I moved back to India. The thing I want to say is what Anandan was saying was not just like high level good feeling, but it was a very precise definition on how to pick a problem for AI for social good. And this is somewhat my version of it, but in spirit, it's the same thing. So you want to start with impact potential, right? So say you want, and this is a way to pick a problem, right? Or this is a way for you to ask yourself, given 3 or 4 different problems, which one should I work on? Is this a big problem? What specific problems that AI is expected to solve, right? And does it have a large enough, will solving this have a large enough impact, right? Is this solution feasible, right? Oh, okay, I would like to solve cancer with AI. Fantastic. And maybe it's feasible, maybe it's not feasible, but you have to ask that question. Are there first principle limitations, right? Is the data collection itself pretty much impossible? Then you shouldn't go down that path. The other thing a lot of us fall into is this AI necessity. Like, because we are trained with AI, like for a hammer, everything looks like a nail. No? So we think everything is an AI problem, but a lot of times it's not. So is AI necessary? If all of this goes through, then you say, what's the overall solution, right? Where in the workflow will it sit, right? So just to connect to the couple of projects I said before, to assist in learning, we said we'll add it to their learning journey, right? So we didn't just think about the LLM for health worker. Even before we wrote a single line of code, we knew what was the full solution, right? We knew what's the system design. Same way in pest management, we knew that these traps are already getting installed. These are the problems, and this is where AI can solve it. Now, even if can solve it, is there acceptance? For example, on the like anthropometry project, which I didn't talk about, but this is a project where it's a newborn baby and you want to measure their weight. One of the problems was of acceptance, actually, because nobody wants their naked baby's video taken, right? Although if they're clothed, then you cannot get a good estimate, so you do have to put them naked. So there's a challenge, right? But it's worth considering this upfront. Of course, at the end, you want to think about who is going to use, who are the user, who's the beneficiary, who is going to pay, and who is going to choose who gets it, who doesn't get it, right? So, for example, this national pest surveillance program was already part of our agenda when we started, saying this is where we can graduate the project. They already have funding for it. So to think about what if we succeed collecting data, then what? What if we succeed in making the model, then what? What if we succeed in making the product, then what, right? So you keep asking the then what, and hopefully you have some answers on each one of them, or know the risks, right? And then, of course, partners, right? This is who's going to pay, especially in nonprofits. Will you have domain experts, right? I'm an AI person, but what do I know about farming, right? So who are the partners? What's the scaling, right? Financial scaling, for example, LLMs has this problem. Scaling issue, right? Who's going to pay, right? Tokens are expensive. Open source is still expensive. How do we do it? So there's a bunch of challenges that you have to think about when you design your data collection to your solution. And finally, this is what I think also is important, is why me, right? Okay, even if all this is right, but this has nothing to do with me per se, right? So then you have to think about sort of what your interest is, what motivates you, or what's your skill set, right? Why you, right? There are several problems of this that would fit a bunch of these criteria, but then why you, right? And I think answering all this, or really thinking as deeply as you can about this, one will allow you to pick problems that has a higher chance of success and that can have social impact. Okay, so let's see. So I wanted to just give you a couple more slides on this. So one sort of fundamental change I went through is not so a lot of AI research, ML research, and research in general, computer science research is about methodology, right? Which is on the left side, right? It's algorithmic development, theoretical understanding, but typically these things, even in LLM's case these days, this is the problem. These are on stereotype benchmarks, narrow sets, massive data sets, and it's generally problem agnostic, right? So for example, ImageNet is just internet cat data, right? But it's not really specific to anything that I want to work on. Versus application-driven ML, and this can be research too, is on real-world setting, is on real-world evaluation, it's on sort of real-world constraints. And so, for example, in the COF project that I said before, I mean, I had a lot of people on the team who want to try very, very complicated models, right? But we never start there. We will always start with the most basic, simple model and say, look, okay, you can try with something complicated, but it has to beat this statistically significantly, right? And it has to then not be 10 times more compute intensive if there is mobile deployment towards the end, right? So thinking about the end solution forces us to think about the kind of data we collect, the kind of metadata we collect. So I would encourage you guys to read this paper. I have a QR code at the end, so you can look at the slides. But this is a different way of approaching your ML work. But by the way, I'm not dishing on methods. I think it's very, very important. I should say this. But these are just two different mindsets. And bringing a methods mindset to application is problematic, and bringing an application mindset to method, it's not a success criteria. So you should know which territory you are in and do the right thing there. Yeah, I think I said this. The other thing, as I showed you, this sort of 6-year journey is it's very, very iterative. It's not one shot. The mental model, and I say this everywhere I get a chance, is it should be empirical. It should be scientific, evidence driven, but you should be open to rehashing anything that you did before. For example, in pest management, we first said, look, internet connectivity is a problem. But then we said, look, we'll give them both choice, right? So we did reconsider and said, look, we'll give them this slow version as well, right? So thinking about model building, data curation, the use case, solution, problem definition, and then they are all kind of interconnected. And notice that I purposefully didn't put an arrow here because there is no starting point. This is like all this kind of jigsaw puzzle, and it fits for a while, and then you keep scaling or you discover new things, and then it goes off, and then you keep doing this, right? And this is the x-axis is effort, and y-axis is certainty or success, right? So as you put these things more and more together, chances go up. Yeah, saying this just another way, I love this picture, so I thought I'll put it here again. Is you have these loops, right? You think of a use case, then you build something, then you measure it, then you learn about it, then you build again, and then you can get out of this loop when you feel like it's high enough success criteria. Okay, then you go into deployment, right? Your model goes through deployment verification, ML engineering, verification. If this looks okay, then you do evals, and evals good. Oh, release. Okay. As soon as it's released and operational, things will break. You'll discover new things, and then you plan again, you collect the data, do the modeling, right? And this is the endless so-called cycle of machine learning. But it's important to not get, what I want to press on this is each piece is crucial. Like think about model and scaling and versioning, and data versioning and data quality, all are equal work. Sometimes I feel like young people get too attracted to shiny algorithms. Yeah, this one, let me see if I want to talk about this. Yeah, I do. Okay, so this is some principles, just putting now, not in a sort of philosophical sense, but more concretely. In general, this is like imperfect solution to the right problem is much more important than perfect solution to a wrong problem. For example, had we built a test detection model on American data, which was really good, it's a perfect solution to a wrong problem, right? The other thing is like this premature optimization is bad, right? Start slow, start simple, keep it low tech debt. So try and use limited amount of cursor. Don't use very complicated unless needed, and justified. And also think of the whole thing as iterative, right? But iterative responsibly, right? And abstaining is a way of iterating quickly, giving it to more users, but then you do it responsibly so that you don't lose the chance again. Yeah, so what, right? This is the 8th question of so what, right? So what? You got the data, so what? You got the ML, so what, right? You keep asking yourself these questions until you feel like you have answered 7 times. I borrowed this slide from Soma. Soma says 7, but maybe you can do it less. When in doubt, at least in applied setting, when the model doesn't work and you're out of idea, collect more data. Collect data rather than adding very, very complicated cross attention. Generally doesn't work. And if you guys haven't read The Bitter Lesson from Rich Sutton, then you should. That'll also get you to believe that. Yeah, abstain. I already told you about this. And think about AI. Like one of the things is with AI, you want to think about how do you augment the people rather than automate them away, right? One, it's from a value standpoint, but the other is also if you try and augment, then you have a slow ramp up to the end, right? Because now I can do maybe 10%, 20%, 30%, and then slowly you can kind of cover a lot of the tasks or a lot of the problems. So really always think about human AI together, and human AI together has this very important aspect of abstaining, right? So the model should, for example, ChatGPT, sometimes the one thing, somebody had asked me this today, what does ChatGPT cannot do, right? Like what can't it do? Very definitively. And I said, it cannot shut up. You see, if I ask it something, it is compelled to respond, right? And it doesn't abstain. So I think when we think about scoping our problem, thinking about abstaining or thinking about the human machine collaboration, in this sense, augmentation would be the right choice. Yeah, and of course, cost aware. So yeah, make your models strong, fast, cheap, better, everything. Okay, this is my last slide. This is my because a lot of people have come up to me. Oh, there are some people that work for me or conferences, things like this, saying, hey, how do I find my way, right? Like, how do I, there's so many things to do, so many problems, and how do I work on it? What do I pick? And at least this is what I feel like is one framework of thinking about it. There is, you start with values. You have to start with what change do you wish to see in the world, right? Could be climate, mental health, financial inclusion. I heard about mental health from a question the other day. Could be pandemic, anything, doesn't matter. But what I like, you want to think about your values, right? And it should be very few, right? Can't be more, 2 or 3, too many already. But these have to be so deep that you're willing to live it, right? For example, if you say that you're for example, you say that you want financial inclusion, or you care about mental health, then you should work on social media, you see. So you have to be consistent with yourself, right? I'm not saying that is the wrong thing. So these values are something that you have to live with, right? This is the point. And then find domains, big, beautiful, unsolved domains that, the way I call it is the hill you're willing to die on, right? One of my close friends has a edtech nonprofit startup, and he uses this word, right? He's like, I know there's lots of other things to do, but this is the high hill I'm willing to die on. Meaning, I'm willing to stick to this for a very, very long time. One of this is a very nice website of world problems that could help you kind of look through it. It's lots of problems, lots of sort of unsolved societally critical problems that you could develop your taste in, right? And this is to say you develop your opinionated taste of, here is a problem and here is how it should be done. It's okay, you're right, you're wrong, but you're willing to go out on a limb, right? And I think that kind of is necessary. And then pursue it, right? Pursue it with all your time, energy, attention, everything. But be open-minded. Be open-minded on how you get there, right? Doesn't have to be a startup, doesn't have to be a nonprofit, doesn't have to be academia. Maybe it's content creation, who knows, right? It's about the values and the domain that you want to go, right? And all of that, at least in my definition, is social impact, right? If you from your standpoint, in your definition. The other thing a lot of young people, cell phone generation, don't do is immerse yourself in the community, right? Don't work alone. If there isn't a community, build one, right? Be around these people, because like, you have to be humble. You don't know everything, and your thinking must evolve. Yeah, and aim higher, right? Like, aim as big as you can, because why not? And the last thing I leave you with is, like, don't chase status awards. I can make enough money so that you can pursue this. This will give you all the happiness and satisfaction that anyway you want. It's just sometimes there's a harder path to it. Yeah, that's it. I'm done. Thank you. Questions? Oh, while you guys think of a question, I had just thrown in this slide. This is the thing that I had made for my job interview, actually, on my way in the flight, because they had asked me, if you were, this is just a weird thing, if you were to lead the institute, how would you lead, right? And so what I had made was, lot of work is in the GitHub cemetery, right? A lot of time and energy goes, but it has really no impact. But what we want to get to is this 4, right? It's this escape velocity, where it keeps having impact, but then we have to spend no energy, right? That's the end state, right? Of anything, really. For example, Wikipedia is as big of a social impact as anything else, and they set it up, and now just the community takes over, right? The founder doesn't have to do much, right? So, which means it has reached escape velocity, right? And this is maybe another way to think about what does success mean.
Yeah, exactly. That was a really great talk. Let's thank our speakers.
Thank you.
Yeah, so who has questions? Yep.
Hello, sir. So my question is related to your previous projects. That
Sure.
First one.
Pest management? Yeah.
Then
I cannot hear.
hello, sir. Am I audible?
Yes. 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 Go ahead.
So my question was related to your previous project that you showed. So after
Yeah.
you take care of the pest, you it also counts the number of pests. So what is the motive behind that? Is it like if the number of pests crosses certain threshold, then the severity of the pest attack is more or something like that?
Yes. Exactly. So different severity have different action associated. It's not just about telling them severity, but what action they can take out of it.
It's, I think we do not have any more questions in the room.
Okay.
So that was a great.
I had some questions. So
Go
Jigar,
ahead.
wonderful talk. I think so. I love the technical bits. I especially in the technical bits, I love the fact when you showed that it was not deploy the model, use a state of the art model, and you're done. So it was also the fact that there was a mobile model which rejected samples. There was also then the whole feedback loop and also the better model. So that entire entire ecosystem is there as opposed to just a single point solution. I think as students sometimes we don't get to sense that there are practical considerations and there is the whole engineering challenges. So I love that bit. The last part I especially liked, how to pick up problems, what kinds of problems, how to go about it, and have enough money. So that bit is, I think, also important so that people don't become crazy
Yes.
and don't have the means. I have a question which I have always found it hard for myself, even though I'm working in the similar domains. So unfortunately, I oftentimes find out that as technologists, we can build up excellent solutions with good motivation, but at the end, sometimes it comes to the policymakers or the governments or the other agencies who have to take the final action. And unfortunately, I think there is often too much resistance, or maybe they don't see.
Yeah.
So I don't know what to do about that. So have your thoughts.
I was hoping you had an answer to it. No, I mean, like it's happened several times to me. So without, I know it's recorded, so I won't get into specifics. I mean, I think the that's just another constraint, is how I see it. Okay, fine. You like the state ministry, some XYZ district official doesn't want to do it, doesn't want to pilot it, or doesn't want to give to their health workers, whatever. We'll find another pathway. We maybe go another country. Why not? So, to me, if I stop believing it, right, which is also the case, right? Sometimes it's like this is not a solution to anything. Then it's worth dropping. But otherwise, I think you take it as far as you can. Is one thing. Pause, leave it open, and see where it goes. Or like I've gone both ways. Is what I'm saying. Sometimes I fought it. And I said, no, we're just going to find another way. We'll go meet another people, go to another country, whatever. And sometimes I felt like, look, like for example, I'll give you an example. COVID. It's a great thing. We had some resistance along the way, but then it just seemed like this doesn't have outsized impact right away. So there I was okay, not pushing it hard. But no, in general, you're right. There are not clear motives on the gatekeeper side. I'm with you. But I don't know what. I would like to find another way where this is not the problem. That the problem is just building, or problem is just innovating, and not the human problem. But I don't know. That's not the world we live.
Yeah, thanks for a very honest discussions. So in fact, I think going forward, a lot of the conferences like KDD also, they also now ask about how a solution is deployed. How are the deployment partners accepting that? So generally, I'm happy in the last few years to see this trend where the deployment is being actually seen. Because I remember earlier years, it was until unless you're in a very system C conference, it was seen as this
Yes.
is not research.
It's not research, correct, for a very long time. Yeah, but that's nice. I think I've seen lots of these workshops. In fact, impact statement, ethical statement, right? All these things coming in a way points to these kind of framework of, are you working on the right thing? That kind of thing. So it's good.
So
Yeah.
another
Compass is good.
Yes.
Like, for example, Compass in India is pretty good on this. Like, I think it's one of the best.
Right. Yeah. So I'd like to again bring to attention to the students of the summer school. So this is another benefit we have from these varied experiences of the different speakers. Couple of days back when we had Venkat Padmanabhan deliver the keynote, he mentioned his learnings, his insights from a similar thing. In 2007-8 or so, they had started this car vehicle monitoring using smartphones, but they mentioned that the technology was not ready. And after 10 years, they had a much better technology, etc. Now it's being taken up. So again, there are different timings to the kind of work people are doing. There are and as Jigar mentioned, maybe there are different stakeholders people could reach out to. So overall, I think it's a nice blend of the speakers' experiences that we're getting through this. I think we should ask him more questions. We should take every bit of his time to every minute that he can offer us to get their experience. Any other questions, Ayush, from the audience?
No, there are no questions from the. Okay, there is a couple of.
Tell me about some research projects that you guys are considering to work on, and why. Maybe we can talk about that.
And if they're not questions from the students, I can also ask one question on their behalf. Let's say if they were to work with you, what would be the kind of skills you'll want in these students?
I mean, in a way, it's not so different, right? Just writing good code, being empirical, being thoughtful. So those things don't change. But in addition to that, I think I generally also like to work with people who care about the problem some way, because they thought about it, they had worked about it, or their family members, something. So this kind of sense of purpose that they have, right? And I think, given that these people have chosen to spend time here, I can sense that they all must have something like that. So that, right? Usual skill set, good programmer, good machine learning person, but also this.
Hello, am I audible?
Yeah.
So my question was that how do we approach these problems as students? Like, most of the time when I think of a problem, I am always hindered by the lack of computation or lack of data that is available to me. So as a student, I cannot go physically collect the data or arrange
Sure.
computation from somewhere. So at this,
Yeah.
how can I approach this hindrance that I am facing?
Yeah. Do you have an example? It would be nicer to work through that. If you had like some idea that you thought
Yes,
if you had a lot of money, then you could do. Yeah.
So I was thinking of developing a security system for warehouses. So whenever some unauthorized vehicle, like there would be a database of vehicles, like that there is a truck with this license plate or something like this. So whenever an unregistered vehicle will come, I'll notify the owner of the warehouse or whoever is associated with this. But I was
Yeah.
hindered by the problem of not getting data set of Indian plates. So most of the plate data that was available was of
Yeah.
or either China or some other country. And I approached to an organization that had collected this data, but surprisingly, they were asking 12 rupees for each image. So totally they had 10,000 images, and they asked me to, as a student, pay 1,20,000 for that data set.
Yeah.
Of course, not feasible for me. So
Yeah, I see. Would you like to get to a point where you can spend this money and like really do it? Right? I assume so, right? Like not this problem, but in general, right? You would like to get to a point where, so in a way, as students, I think you want to think about how can you showcase or like who or which organization or where, which institute or which collection of people you want to work with, right? Where there is resources. Because you're right that it's not just about your salary, but it's also about compute and resource. So I would think backwards that way, meaning you want to work on something that's a stepping stone to then go and really solve big problems, right? But that stepping stone selection also, see, mentally, you can imagine as big as you like, right? And then you can take the smallest possible step that you could do. For example, in your case, the thing that I could think of is go, like physically go and collect a lot of Indian number plates, right? You could collect 100 in a day, right? Easy. Okay. Using that, create synthetic data, right? Take the US one, take the Indian one, create a synthetic one, then show something there. Okay, that's not fully real, but that's the best you could do. You see? So this way you can make progress, right? Like there is always the smallest step to make progress. Look, this is not the actual thing because I don't have the resources, but here's the best I could do. Go collect 100. Show it on that. You see?
yes, so basically I have something to prove myself so that I can show the other guys that I'm capable of doing this, and
That's right.
maybe help me further.
No, not just that, right? Not capable, not just capable. It's also to show your intent that you are the kind of person who, with resource, not with resource, keeps moving, right? So it's also not just your like actual skill set, meaning that you can write code. Everybody can write code, but that you can pursue it, right? This is leadership. So it's showing these things. I mean, and this is life skill. Everywhere, if you apply this, you are in your top percentile.
Yes, very well thought. Thank you.
Or, I mean, the other thing, which is quite underappreciated, cold emails. Cold email, like I think people don't just thoughtful, not the generic one, which I do get a lot of students, and I can tell that this is just a generically written email, but a thoughtful email saying, look, this is such and such, and I'm interested in doing XYZ. Can you help? You would be surprised how many people will respond. So this is always knock enough doors in general. Don't be afraid. Worst cases they'll ignore. It's okay. Yeah, but knock the door.
Hello.
Somebody was asking something. Yeah, go ahead.
Rishiraj this side. Amazing talk. And we have seen this example of the cotton project and the anthropometry project, or even cup for cold. Now, these are very good examples of project that succeeded, that made impact. In lines of what Professor Nipun was also asking, there are projects that fail. So can you, if possible, can you discuss briefly one of those projects which
Of course.
very nice note, it could change the society or there's a huge societal impact, but then you somewhere in the pipeline you realize this is not going to take off. Is there any
we didn't go too far. I mean, quite honestly, I think I was fortunate enough to be in like this environment where people constantly kept asking these questions, so it was very hard to go down that path for months. I'm trying to think. There are minor detours, right? So not the overall project, I can say, but for example, in anthropometry itself, I'll give you the example because early on in anthropometric, just for the students, I know you might know the project. This is where you want to measure head circumference, weight, volume, that kind of thing of a baby. Early on, well, I wasn't part of it, but when I joined, this was the direction we were taking. Was we wanted to make a 3D model of the baby first, right? So measure key points and also create a very high resolution Indian baby data set, and then map the on-field data set to this 3D model of the baby, and then use this to do. Now the issue was that to collect this very high resolution images, we had bought this like 300K custom made 16 camera thing with lights at the bottom. Is a mirror here, and so we had got this from Atlanta from a company. And it was a big investment. We had a bunch of models, bunch of things, but really it was the wrong approach because well, at least from my standpoint, we couldn't really collect enough baby data from the hospital. This was in Wadia Hospital in Mumbai, and it's only one equipment, so we can't really move the equipment around. And we would get like 6 babies a week. When like it was a like we didn't think through whether we would be able to collect enough data such that we could fine tune. I think that kind of was misestimated. So it was total failure. Like that equipment is still probably somewhere. We didn't use it at all, and we just abandoned it. What worked, you know, sadly or happily, whatever you want to call it, good old-fashioned dumb deep learning. No 3D model. You just take a bunch of frames, video model, regress to a number. It's just worked. And that data could be collected right in the field, right? Exactly on the phone that we like. So none of this 3D detour. It was a big detour, like a 10, 15 people team for eight months or a year. So maybe not at problem selection. I don't have an example, but we have taken some like wrong technical decisions. Too complex, I think. We didn't start simple. We missed this lesson there.
Right. that was-
Also, I wouldn't, the other thing is, I wouldn't say COVID cough is a big societal impact thing, but we couldn't really do it, I think. Partly was because there was some organizational misevaluation on how much funding we'll need to do clinical trials, basically. Because it was very clear even at the start that if this had to go through and be really useful, then we have to go through clinical trial. And we had some partners who said yes, but then they said no. And so we really, it didn't technically succeeded, I guess, but solution-wise, no.
Right.
Because it did,
I mean, most of the time in academia, we are also on the same page most of the time. So I hope we are not the only one who's facing this.
no, we all do it. In fact, something that I said this somewhere else, right? Like, like we feel like there is a low hit rate, like number of projects to success, right? Like the hit rate. But I think innovation by definition is like this, right? We are all walking in some kind of fog and making some half assumptions and sometimes optimistic assumptions. And that's okay. I think my feeling is we just have to have a lot more people with many shots at the goal. It's just like, it's not certain, right? If you're doing something new, if you're doing something innovative, failure is likely. True for startups, true for anything else, actually. Yeah. Anyway, I don't know. Somebody has a question.
So,
Go
can
ahead.
you hear me?
Yeah.
So, this is not so much a technical question, more about the values or the moral dilemma question. You said
Go
like
ahead.
the values and stick to the domain and the hill you're willing to die on. So, mine is
Yes.
health, but mental health in AI has always been a debate inside my head. I come from a clinical psychology background, and introducing machines into this domain sometimes feels like a violation of the sacred to me. At the same time, I'm
Yeah.
also seeing and working on projects. So right now I'm working on a tech project. I also like mentioned a depression diagnosis project. There are a lot chatbots who are therapists now for some people. I
Yeah.
the intention of such work, but as a psychologist, I also see that how wrongly it's being executed because there are not the right kind of red tape around it, or the knowledge,
Yeah.
or the access to information that not everybody should have. It gives to the end users. S- So I have switched gears from being a practicing psychologist to research for the sole intention that my work should be able to have an impact for exponentially more people than those who are working on it. But the sole dilemma is like, am I introducing technology in the right sphere? Like, how do I think about it? Because
Right swear?
right
Sorry,
sphere,
you said?
sphere, S,
Right sphere.
yeah,
Right sphere. Okay.
so because also as much as AI is being introduced into mental health or awareness and everything, there is
Yeah.
also a increasing world of knowledge that it's not good. It's not doing as much good as it is doing wrong for the people.
Yeah. I agree. Funny you say this. We have an ongoing collaboration with Center for Mental Health in Pune. This is like the suicide prevention. Yeah, you might know about that. And we have been thinking about the same, like, so I can give you some thought process, but then also say that when I said purpose and all these things, I didn't say technology anywhere there, right? I didn't mention it. So yeah, don't do it. If that's what you, if you feel like adding technology is a negative, then actually you should like create content and tell people that this is wrong. That's fine. That's your values. That's the hill you want to die on, right? That's okay too. But I think I'll just share some. I'm not a clinical psychologist, not an expert. One of the problems that they came to us with was that a lot of therapists are undertrained, or that we feel like they, especially on like suicide prevention kind of problems, we feel like they don't do the right thing. Meaning, if there was well-trained clinical psychologist versus somebody who's answering the suicide prevention call center, there's a skill gap. Okay, so they said, what can we do with AI? Can we do something? And this is the kind of, like, of course, first thing would be like, replace the person, bring the bot, right? I am with you. That is wrong. That's going to do more harm than good. But how can we assist, right? How can we increase the capacity? Can I help them better, right? So can I, it could be as simple as when they get a phone call, can you remind them the right thing to do, right? And if their care is increased and you have added the minimal amount of tech, that is still success in my definition. So in fact, you are the kind of people that should build tech, not my kind of people. You know the problem. So anyway, if you send me an email, I would love to chat with you. We are working on this, so if you're interested, would love to see if we can collaborate.
I would love to get any kind of glimpse or involvement in this. Thank you so much. And yes, I agree with your perspective that it need not be a replacement. It can be complementary, not sub. Yes. Thank you.
Yeah, no, not replacement. Yeah, just complement. As should be.
Thank you.
So we don't have any more questions.
Fantastic. Thank you very much. Oh, Nipun's here. Say something.
No. I was here to just say you bye and thank you for the wonderful session over the 2 days. And so I'll also share, I believe people can figure out your email ID anyway. So in case
Yeah, but I can just put it, yeah, here. I can put it here, Jigar K. Doshi. My website should have it, but if you want, just it's the same website at Gmail.
Okay,
Cool.
thanks a lot. And hopefully all of us will collaborate over future, discuss more. Okay, thank you.
Would love to. Yeah, thank you for the opportunity, by the way. It was fun just thinking about it and trying to consolidate a lot of what I have done. But yeah, thank you.
Thank you. Bye.
Bye.